We have another problem here. A beam made from ASTM A36 structural steel plate with yield strength of 248 megapascal. Okay, he is giving me the stress actually. Okay, yield stress, that is sigma y, which is actually our maximum stress because we cannot cross yield stress because the material will enter into plastic state. Is to be designed to carry concentrated loads shown in the figure below. You can see here there are two forces, two loads over here. See, one is how much? 5675 Newton. Another one is also 5675 Newtons. Okay. The beam has a rectangular cross section having a thickness of 32 millimeter. Okay, 32 millimeter is telling. See here we have 32 millimeter. That is B. You can calculate the suitable height. In our case it is D. That's what we say. Height is equal to question mark. We say it is depth. Note, use the design factor of safety of 2 in the calculation. See, you have to use factor of safety over here. This is the most important thing. Okay. If you have this beam, now if you see, since it is a concentrated load, so what will happen? You will have if you draw a bending moment and shear force diagram, you can see that the bending moment will be maximum at what point? If you come over here and if you take over here, the bending moment will be just maximum at this point as well as this point. It is same. Why? Because the forces are same and the distance is also same here. See, same here, is it not? If I put my hand over here at this point, bending moment will be what? RA multiplied by 1.2. RA multiplied by 1.2. At this point also it will be RB multiplied by 1.2. Is that not? Okay, it's a very simple problem actually. So now let us see. Now sigma y is what? Sigma y he has given 248 megapascal. B is known. Factor of safety is 2. He wants us to find out H, which is also is equal to D. This is the question mark, is it not? Now let us see here. Maximum bending moment is what? At point B as well as at C. We call them as MB, MC. What is MB? MB is nothing but MB is nothing but RA into 1.2. MB is equal to 5675 into 1.2 meters. This is meters, is it not? Okay, so it becomes how much? 6810 Newton meter. From meter you convert to Newton millimeter. So we multiply by 1000 because 1 meter is equal to 1000 milli. So you got the maximum moment, is it not? This is also is equal to MC. It's also is equal to MC because from the other side if you come it is the same thing. Now let's go. Now what is the working stress? Working stress is equal to or design stress for that matter we call it is equal to 1 sigma y divided by factor of safety. Okay. So we have 248 divided by 2. So we get 124 megapascal. So now I have the formula. What is the formula? M by I is equal to sigma by y. Okay. Therefore, so now here what are the things we know? M we already know. And I is also, I we don't know because BD cube by 12. Is it not? I is equal to what? BD cube by 12. So here we know only this. This is not known. So you cannot find out. Sigma is already there. I know it. Okay. And Y is known. Y is also not known. Okay. So what can I do now? I can say I by Y max. Is it not? I divided by Y is equal to what? Sigma divided by M. Correct? So now I by Y is what? I by Y is nothing but section modulus. So let us anyway write sigma. Okay, y by I max is section modulus. So now I can easily find out the value. So let me delete this because it is here. I will explain you straight away here. Okay. So what did I do? I bring sigma max below. If I bring sigma max below, what will happen? M by m divided by sigma max is equal to I divided by y. I divided by y is what? It is nothing but we call it as z, that is section modulus. So now we know the value 6810 is already there, present here, and then 124, where it is that? It is present over here. Okay. So now we get the value of what? We get the value of z, that is section modulus. Okay, we have it. Now we know that for a rectangular section, what is the value of I? Let me write. Z is equal to b cube divided by 12. Is it not? Y is what? Y is nothing but d by 2. So this 2 gets cancelled here. You have Sitta here. 1 is going here with this one, and you are left with 2. Z is equal to bd square by 6. B is already given in the problem. How much is that? I think it is 20. Correct. Let us just see. B is how much? B is 32. Let's go back. B is 32 into d square divided by 6. So therefore, what can I do? D square is equal to 6z by 32. Is it not? D is equal to square root of 6 multiplied by value of z is 32. What is the value of z? Section modulus, we calculated it. Where is that? Section z is here 54. Sorry, let me just remove this. What happened to this? I don't know why it's not going. Let me just go back here. Let me write d square will be is equal to how much? D square 6 into z, is it not? Z is 54.93 into 10 cube. 10 cube into 54.93 multiplied by 6 divided by 32 under the square root. Okay. So when you make the calculation, what is the value of D? It is coming at 101.48 millimeter. Okay. So this is the way we just solve the problem. It's a simple problem here. Yeah, you did not know y and you did not know I. Then you found out section modulus, and then you from that you find the value of